Hello student, good morning. I am Dr. Sinha, Professor of Chemistry. Today I am going to discuss alkenes. Alkenes. Last class I have discussed chemical properties of alkenes, and also I discussed conformation. Before starting alkenes, I want to finish relative stability of conformation. Okay, it was left. Now I will finish it, then I will start alkenes. Relative stability of conformations. In a staggered form of ethane, I have discussed staggered form and eclipsed form, and in the middle it was skew formed. Okay, three form I have discussed: eclipsed form, staggered form, and between these two, that was the skew conformation. Then in a staggered form of ethane, the electron clouds of carbon-hydrogen bond are as far as possible. Thus there are minimum repulsive forces because both are far. Carbon electrons and hydrogen electrons are far. That's why repulsion will be less. Thus there are minimum repulsive forces, minimum energy and maximum stability. Minimum energy means always a maximum stability of the molecule. Keep in mind, if energy is minimum, then stability will be more in any molecule. On the other hand, when the staggered form change into the eclipsed form, staggered form means when we come closer. When the staggered form change into the eclipsed form, the electron clouds of the carbon-hydrogen bonds come closer to each other, resulting in increase in electron cloud repulsion. Then obviously repulsion is there, then it will be unstable. To check the increased repulsive forces, molecules will, just to stop or to check, to stop the increased repulsive forces, molecules will have to possess more energy and thus has lesser stability. Correct? This you have understood, that in a staggered form is what? That is the these things, because they will come close. From the staggered form, when it will come to the eclipsed form, staggered to eclipsed, that time it will be repulsive force will be more, means that is the that will be weak. Okay, repulsive force interaction between the electron clouds which affect the stability of conformation is called torsional strain. Already I told you, but here you understand, to check the increased repulsive forces, molecules will have to possess more energy and thus has lesser stability when it will come from staggered to eclipsed form. Okay, but in a staggered form they will be far. Means that is the stable staggered form of ethane, that is the stable region. Already I told you that electrons will be carbon hydrogen, electrons will be far, repulsion will be less. Again I am telling you, in a staggered form of ethane, the electron clouds of electron hydrogen bond are far apart as possible. Okay, because CH bond and other carbon CH bond, they will make distance far apart, uh, far apart as possible. Thus, there are minimum repulsive forces. It means minimum energy and maximum stability of the molecules, that is in a staggered form. But on the other hand, when the staggered form changes into the eclipsed form, the electron clouds of the carbon-hydrogen bonds comes closer to each other, resulting in an increase in electron cloud repulsion. To check the increased repulsive force, molecules will have to possess more energy and thus has lesser stability. Means conclusion is that staggered form is stable and eclipsed form is unstable. As already we have told you, the repulsive interaction between the electron clouds which affect the stability of conformation is called torsional strain. Question is asked. All this in which form this which form is stable, staggered or eclipsed? Then now you can answer. This question is asked. What is a torsional strain? That question is asked. Then this I told you that repulsive interaction between the electron clouds which affect stability of conformation is called torsional strain. What is a torsional strain? Now understood. Magnitude of torsional strain depends upon the angle of rotation about carbon-carbon single bond. This angle is called dihedral angle. Again, this question is asked. Whatever I am telling important, always you note down. Okay, because that question will be asked. Then angle. This angle is called dihedral angle. Okay, that magnitude of torsional strain I am telling you. Magnitude of torsional strain depends upon the angle of rotation. Angle of rotation about CC bond, carbon-carbon bond, and this angle is called dihedral angle or also called torsional angle. Of all the conformations of ethane, the staggered form has the least torsional strain because it is stable. Hence it has a least torsional strain, and the eclipsed form, the maximum torsional strain. Okay, because more repulsion is there. Thus, it may be told or it can be said that rotation around carbon-carbon bond in ethane is not completely free. Okay. Then we can tell like that that is not free. This rotation around carbon-carbon bond in ethane is not completely free. Restriction is there. The energy difference between the two extreme form is of the order of 12.5 kilojoule per mole. That is just between the staggered and eclipsed. What is the strain difference? That is of 12.5 kilojoule per mole. The energy difference between the two extreme form is of the order of 12.5 kilojoule per mole, which is very small. Even at ordinary temperature, the ethane molecules gains thermal or kinetic energy sufficient enough to overcome this energy. This energy is not too much. Simply by heating, this you can overcome. Okay, very small, and even at ordinary temperature, the ethane molecules gains thermal or kinetic energy sufficient enough to overcome this energy barrier of 12.5 kilojoule per mole. through intermolecular collisions. This energy, because if you will heat, then what will happen? Collision will increase. This will happen through intermolecular collisions. Thus, it can be said that rotation about carbon-carbon single bond in ethane is almost free for all practical purposes if you will heat it. Okay. If we will heat it, then what will happen? That rotation about the carbon-carbon single bond in ethane is almost free for all practical purposes. It has not been possible to separate and isolate different conformational isomers of ethane. Now till that it is not possible. Okay. This I have discussed about the conformation. Now I am going to start alkenes, double bond. Alkene was having carbon-carbon single bond. Now here carbon-carbon double bond. Even long chain is there, then at least one carbon-carbon double bond should be there. Even 4-5 carbon chains are there, but at least one double bond is required. Then that will be called alkenes. Okay. Alkenes are unsaturated hydrocarbons. It is well known. Means why unsaturated? Because it will have double bond. Alkenes are unsaturated hydrocarbons containing at least one double bond. What should be the general formula of alkenes? Just to think. Then, if there is a one double bond between two carbon atoms in alkenes, they must possess two hydrogen atoms less than alkenes. It is clear. Because double bond is there, then one hydrogen bond gone. That's why it became the form double bond. Hence, there will be two hydrogen less than alkene. Hence, general formula for alkenes is CnH2n plus 2 has gone because now 2 hydrogen is less. From the alkane, 2 hydrogen is less. Then in alkane it was CnH2n plus 2. That plus 2 gone because 2 hydrogen is less. Then what is the formula now? Only CnH2n. Whatever is n value, make it double. That is the number of hydrogen. CnH2n. Now, alkenes are also known as olefin. Question is asked. Alkenes are also known as olefin. O-L-E-F-I-N-S. Olefin means while forming. O-I-L, while forming. Okay. Since the first member of ethylene or ethene is C2H4. Ethylene or ethene is called, that is formula is C2H4, CnH2n. And obviously C is equal to 2, carbon is equal to 2, then H is equal to 4, then C2H4. Then again one more question is asked. I am going to tell you that now it's ethene or ethylene formula I told you C2H2, and this was found to form an oily liquid on reaction with chlorine. This ethene was found to form an oily liquid. That's why it is called olefin. Okay. Now that first what I was telling you, that this about this member, general formula I told you, alkenes are known as olefins. I told you, since the first member of ethylene was found to form an alkyl liquid. That's why it is called these things olefin, because it formed oily liquid. Okay, this question is asked, why it is called olefin. Now I am talking about the structure of double bond. Already many times I have discussed. Again, this is the right place to tell you. Okay, carbon-carbon double bond in alkenes consist of one strong sigma bond. One strong sigma bond. Its bond enthalpy will be around 397 kilojoule per mole. It is a strong. Sigma bond is strong than pi bond. Already I told you. Here you know that in two bond, one bond is sigma bond, other bond is pi bond. Now I will go little details. Then sigma bond, its enthalpy is about 397 kilojoule per mole. This is because due to head-on overlap of sp2 hybridized orbitals. Each carbon will have sp2 hybridized orbital. Head-on collision. Okay, head-on overlapping or head-on collision, you can tell sp2 orbital of one carbon, sp2 orbital of other carbon, both will overlap head-on or axis wise also you can tell, then sigma bond is formed. But in alkane there was sp3, one carbon sp3, other carbon sp3 orbital was overlapping, head on overlapping or axis wise overlapping. Always axis wise overlapping or head on overlapping, sigma bond is formed. Then difference is that there it was sp3 and here sp2 means 1s and 3p. There hybridization took place between s and 3p in alkane, but in alkene s and only 2p has taken part in hybridization. 1p has not taken part. That p has not taken part and was having one electron. That's why now sp2 they are making sigma bond. Then what about that p orbital which has one electron on each carbon? On each carbon one p orbital is remaining. They have one electron. Then they have not taken part in the bond formation. Then what they will do, this p orbital, they will sidewise overlapping they will do. Sidewise overlapping or also called lateral overlapping. Overlapping will be less in comparison to the this axis wise as head on. Here overlapping will be less, sidewise overlapping will be less. That's why they will make bond. But this bond, because overlapping is less, it will be not strong. It will be weaker than sigma bond. Okay, then it will be perpendicular on the axis. CC bond is there and that carbon there. It will be just perpendicular. Then they will form one pi bond. Okay, this I have briefed you. Now details now I am telling you. Okay, due to head-on overlapping of sp2 hybridized orbitals and one big and this sidewise or they are not sidewise. I am talking about this sigma bond. First I will tell about the sigma bond. Due to head-on overlapping of sp2 hybridized orbitals and one big pi bond, its enthalpy is less, 284 kilojoule per mole. This value sometimes is asked in examination. That time sigma bond 397, around 400 kilojoule. This is the 284, more than 100 difference, kilojoule per mole. Okay, this obtained by lateral or sidewise overlapping of two p orbitals of the two carbon atoms. that the double bond is shorter. Again, important things. Double bond is shorter in bond length. Its bond length is only 134 picometer. 134 picometer, 10 to the power minus 12 meter. Okay. Then double bond is shorter than carbon-carbon single bond. Its bond length is 154 picometer. This also you remember. 134 is always double bond will be shorter than single bond. Pi bond will be shorter than this sigma bond. 134 picometer. The double bond is shorter in bond length. Double bond overall 134 picometer and single bond 154 picometer. Shorter distance. Shorter means electrons are closed. Repulsion will be there. That's why it will be very, very reactive. Double bond will break. Pi bond will break soon. Only by value you can understand. Okay. And 134 means here repulsions are distance. They are far. Hence repulsion will be less. That's why it will be stable. Okay. Pi bond is weaker bond due to poor sidewise overlapping between the two p orbitals. Already I have told you. Thus, the presence of the pi bond makes alkenes behave as a source of loosely held mobile electrons, because the repulsion is there. Shorter means they are close. Repulsion will be there. That's why it will be reactive. Easily it can give electron to the others who will come for the reaction. Therefore, alkenes are easily attacked, or you can say alkenes are easily attacked or will react fast by reagents or compounds which are in search of electrons, because easily they will give the electron. Such reagents are called electrophilic reagent. Such reagents which are coming to react because they want electron E positive, E plus, that is the electrophile is represented E plus, and nucleophile is represented as Nu, one pair of electron, and minus. Nu, two electron and one minus sign will be there. One pair of electron, one minus, because it can donate the electron. Then this will function. Alkene will function as a nucleophile, and other which are coming to take the electron E plus, that will be electrophile. The presence of weaker pi bond makes alkenes unstable. Obviously, it will be unstable molecules in comparison to alkanes. Alkanes are stable, alkenes are unstable, and thus alkenes can be changed into single bond. From the double bond, easily it can be changed to single bond compounds by combining with the electrophilic reagents. Strength of the double bond, that is a bond enthalpy. Strength means bond enthalpy, 681 kilojoule per mole. A strength of the double bond, I am talking about the strength and not the bond length. Okay, a strength of the double bond, that is the bond enthalpy, is 681 kilojoule per mole, is greater than that of a carbon-carbon single bond. Carbon-carbon single bond strength is less, but strength-wise double bond is more. That is only 348 kilojoule per mole. Carbon-carbon single bond 348. It is a weak, but it will be not reactive. But double bond is a strong. 681 kilojoule per mole, and single bond is only I have told you 348 kilojoule per mole. But reaction wise, that double bond is more reactive than single bond. But strength wise, double bond is more stable. Okay, this bond enthalpy is more. Strength wise, it is more double bond, and single bond is less. Okay, but reactivity wise, double bond will be more unstable. Okay, only strength will be more. Double bond has more strength. Okay, this question is also asked strength wise, but reactivity wise, reactivity wise also you can tell double bond is more reactive, strength also more, and reactive also. But due to this reactivity, they can break the bond easily. Correct? This is a very important. Why double bond breaks fast due to the tension, repulsive force. But strength wise, it is more than single bond, because double bond, obviously it will be strength will be more. Now I have already, I think many times I have already sent that formation of single bond, pi bond, sigma bond diagram already I have sent, or vital diagram. Last class also I have sent. Then I think already you are knowing, but I will try to again, I will send this formation of pi bond. Last class I have sent in video, you have seen, you can see single bond, pi bond, sigma bond, all things I have sent. Again I will try to send. Okay, I think not required, but I will send. Then now I am going to discuss this nomenclature of ethylene. Already I have told you that every compound, whenever you will study every compound, alkane, alkene, alkyne, that time also you have to, especially you have to focus on nomenclature. Then it is actually way to study. Then you will understand more and more about the compound. Then now you are knowing, but again I am just brief it about the nomenclature, because it is the right place. Whenever you will study any compound nomenclature, you have to, nomenclature of that compound you have to study. So then it will be clear, all the things will be clear in your mind. Okay, for this thing, for nomenclature of alkenes, already you have already told you, longest chain of carbon atoms contains the double bond is selected. You know, when you are going to do nomenclature, then longest chain you have to consider. You have to select which is the longest chain. Okay, but one double bond should be there. The longest chain of carbon atoms containing the double bond is selected, and numbering you will start from the double bond. Double bond is then from that end. Double bond should be closer to the end, and from that end numbering you will start, where double bond is closer to the end. Okay, that should get a list number. Then where double bond is there, then from that side where it should be close from the first end or last end, it should be closer to the, you can say, end. From that in numbering you can start. Numbering of the chain is done from the end which is nearer to the double bond. Okay, this is very important. And suffix ene, that will be converted to the suffix ene replaces ane. Ethylene, ene is there, but now if you do nomenclature, then that will convert to that is the ane. And I will tell some name of this compound, then you will understand. Okay. The suffix ene replaces ane of alkanes. Means what is the difference that we already know? Alkene, in alkane ane is there, but here alkene ene is there. It can be can say, remember, already we have discussed that first member of alkene series, this question is again asked, that is the CH2 series I am talking about. First member of the alkene series is CH2, that is called methylene group, methylene. Okay, that is very reactive, replacing NY1 in CnH2n. CH2, then CS from the CnH2n, that is the alkene. But here, if carbon is 1, if carbon N is equal to 1, then what will be the first member? CnH2n, N is equal to 1. Then you will get CH2, CnH2n, and N is equal to 1. Then you will get CH2, 2n means 2 into 1, CH2, that is the first member. It is called methylene group. Okay, then here, this is, I already told you, this is called methylene, very reactive, but has a very short life because it is very reactive. Okay, as already we have discussed, first stable member of alkene series is stable. First member is methylene, but it is a very short period. CH2 is the first member, unstable, but stable. First stable member is C2H4, known as ethylene, and common name is ethene. Common name is ethene. That is the IUP, not ethylene is the common name, ethylene, and IUPAC name is ethene. Remember it. Ethene is the IUPAC name, and ethylene is common name, ethylene. Then now I am giving few examples of alkene. See, if you can say 3 carbons are there, and 1 double bond is there, then what will be the name? There is a 3 carbon is there, but it has a double bond. Hence you can tell alkane, you were telling 3 carbon alkane, single bond, but here 1 bond is double bond. Then propene, ENE. Propane was you were calling ANE, now it replaced by ENE, propene. Now, if it is suppose 4 carbon is there, 4 carbon and 1 this is there, double bond, with first carbon it is attached, then what will happen? 1 double bond and 4 carbon, then you can tell butene, okay, or you can tell BUT-1-ene, common by butene you can tell, but IUPAC name I am talking about. BUT-1-ene. What is actually coming first? Like butane, pentane, then short name you tell, BUT, PENT, pent, HEX, HEF, hept, like that you have to use. Okay, ANE you remove actually, ANE or ENE, whatever that is removed, only you write BUT, butane, ANE you remove BUT, heptane, HEPT, okay, and A, that is always you remove last 3 letter. Then now butane, first we write that long chain, what is that? After that, where that carbon is a double bond is there, that carbon number you write. but-1-in, because it is in the double bond is with first carbon. Starting, it is with the starting, that is the first carbon. Then you double bond, you count from that, not from the second. It has started from where it starts. It is between first and second, but it will be called first only, carbon number 1. Then butane, but-1-in. Now again suppose that double bond is with second carbon, starting with the first, second carbon. So between the second and third, you can tell only second. Then now again IUPAC name will be but-2-ena. Same things. In the place of 1, you have written 2. Now again suppose this carbon number 1 and carbon number 3, double bond is there, 2 double bond is there. First is at carbon number 1 and second is third, means 3, between 3 and 4th. That will be called third, not the 4th. Okay, student will get confused. Just you tell that is the from the beginning. Beginning is the first, then second, then third. Then third carbon double bond is there, first and third. Okay, between it is third and fourth, but fourth you can't tell. You can tell third only. Starting is the third. From where numbering is started, that way you think. Then first and third double bond is there. Then again, what we will do? Naming. The naming we will do that BUT. This again will tell this thing. Four carbons are there. 4 carbons there. Then again same way BUT-1,3 di-in. Or one more way is there. If one bond is there, then you have told but-1-in or but-2-in. But now if 2 are there, then minor you can say change is there in these things, nomenclature, IUPAC nomenclature. Now you should tell not BUT, you tell buta-1,3, di-in. Di means 2, in, because 2 in are there, double bond. Then here when 2 are there, double bond is there, then IUPAC name will be BUTA, buta-1,3. 1,3 di-in. You know that always separation time dash you have to write. Die-in. Now one more example I am telling you that 2 more I will tell you, it will clear. Now again total 4 carbons are there. One carbon number middle carbon you can tell CH3 group is attached. Then total 4 is there. And with carbon 1 double bond is there. With carbon 1 double bond is there, and in the middle, that is the carbon 2, because 3 chains are there, carbon chain of 3 carbon, and fourth one is attached with the center. Then first carbon is double bond and second carbon methyl group is attached. Then what will be the name? Then name will be 2-methyl. 2-methyl. Okay, always this separation you have to do. 2-methyl. Okay, and prop, 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 only one double bond is there in the chain. Then PROP, prop. Okay, shortcut name. Last you have to remove, I already last 3 letters you remove. Then 2-methyl prop. Now where is the double bond? Then double bond is at carbon 1. Then you will write 2-methyl prop -1 -in. Correct? Because carbon number 1 double bond is there. Now same way now it is a 5. Total 5 are there. But carbon number 3 has methyl group. Carbon number 3 has methyl group. And carbon number 1 is double bond. Carbon number 1. Hence, what will be the naming? The naming will be 3-methyl. 3-methyl. First you have to write 3-methyl, carbon number 3 methyl group is there. You know that series you will write, long chain you will write in the end. Okay. Then 3-methyl, carbon number 3 methyl group is there. Then 3-methyl, and after that long chain 4 carbons are there. Then BUT, but, and carbon number 1 double bond is there. Then 3-methyl BUT-1-in. 3-methyl but-1-in. Okay, this I have told you about the IUPAC name. Now one question is there that is important for your examination. This is the problem actually. Problem means always question. This type of question will be asked in examination. Okay. What is the question that I am telling you? That is you have to write the IUPAC name. Okay. Write IUPAC names of the following compounds. Only one compound is there, 2 compound is there, 2 not, 1, 2, 3, 4. 4 compounds are there. And actually this is very easy. This type of question is asked, many times has been asked. Then here, what has been given question, that is the first question is CH3 2CH. Again, one single bond is there, again CH. Again double bond is there, CH. Again single bond is there and CH2. Again and after that CH is there. And again after that double bond is there. And again they have given CH bond. Again from that single bond CH is there. From that C2H5 is there. And again from that and the end CH3 is there. Then you should not feel that actually it is a long. Question is a long. Chain is long. But this is a given. This will be given. This is given in question. You have to not bother at all. Where double bond is there, where single bond is there, all thing is given. And second question also, that is a skeleton structure. Just you can say 1, 2, 3, 4, 5, 6, 7. 7 points are there, and double bond is alternate double and single bond is there. Just like a web, double, down, single, double, single, double, single, like that way. 1, 2, 3, 4. 4 double bond is there, and single bond is 1, 2, 3. 1, 2, 3. 3 single bond and 4 double bond is there. Okay. And already told you point indicates a carbon. In the beginning or in the end already the double bond is there. Then that also it will be carbon. And each point, they have not mentioned CH3, H2 and this, only skeleton is there. Then now 1, 2, 3. 3 points are there, means 3 carbon is there, and each carbon you know that automatically hydrogen will be there. And in the beginning and the last double bond is there. Then there also carbon will be there. Carbon will be there. Then now this is a question number 2. Question number 3 is just like a straight line only. That is the CH2 double bond C, again CH2 whole 2, again CH2, and again you can say this. No, first they have given question number 3 I am talking about, third part, CH2 double bond, and after that carbon, with that carbon this CH2 CH3 means that CH3 propane 3 carbons are there, whole 2 they have given, CH2 CH3 whole 2 means with that carbon CH2, CH2, CH3 is attached. 2 moles. Okay. Because double bond is there. CH2 double bond. And then CH2, CH2, CH3 whole 2 is there. Okay. Then propyl group is there actually. It is propyl group. Then it is 2 times just like CH2. Then they have replaced the H, and in the place of H they have written CH2, CH2, CH3. Again CH2, CH2, CH3. This is actually propylene group. CH2 is there, which is attached with the carbon CH2, and again CH2. Not really propane only, because it is C with carbon. CH2 is attached, again CH2, and then CH3. Correct? Then two molecules, two branches are there, same, CH2, CH2, CH3. Then now this is the third part I have told you. Fourth part is again very long. That is CH3, CH2, CH2, CH2. Again from that CH2, one branch is there. That is the CH3, CH double bond, again C. Again from that one branch is there, CH2, CH3. Again single bond is there, CH2. Again single bond, CH3. Again branch is there, CH3. Then here you should not be afraid of the question. Okay. Then here you have to write the IUPAC name of the following compounds. 4 compounds they have given. Then here actually all are alkene. Only number of carbon you have to count. And where double bond is there, that you have to count. You have to consider at which carbon double bond is there. That is important. How many carbons are there? That is important. And what is the name branch is there? Then what is the name of the branch? Maybe propyl. Already I have seen in some cases propyl is there. Then that you have to understand. Chain may be long, that is not a very difficult thing you can do. Then first question, answer I am telling you now. First question I have told you, question, I will not repeat the question because it is long, but here I am giving hint that carbon number, where is the double bond? Double bond is near the distance 2 carbon, 1, 2, 3. Okay. Actually 3 and carbon number 3 and carbon number 6 double bond is there. Carbon number 3 and carbon number 6 double bond is there. And carbon number 2 and carbon number 8 they have a methyl group. Carbon number 2 and carbon number 8 they have a methyl group. 2 methyl group is attached. I am telling you just simply. And total number of carbon is decadiene. Deca means deca. You can count how much become 10. 10. Okay, deca means 10. Then here in the end deca you have to use, and two double bond is there. Then diene you have to write in the end. Decadiene you have to write in the end. And starting, how will you do name? End will be decadiene because total 10 carbons are there. Total 10 carbons. Then branch you have to not write. What is the branch? That is the methyl. That you have to not count. Leaving the methyl group, total 10 are there. And 2 this is there. two double bond is there, the decadiene, that will be in the end, decadiene. But starting, how will you do? Then carbon number 2 and carbon number 8, methyl group is there. Hence you will write 2, 8 dimethyl, 2, 8 dimethyl, but 2, 8 dash dimethyl you have to write. And after that, what you will write? That is where is the double bond? Then double bond is at carbon number 3 and carbon number 6. Double bond is there. Then nomenclature will be 2, 8 dash dimethyl dash 3, 6 decadiene. Decadiene, 3 and 6. Double bond is there. Then 3, 6 dash diene. Long is there, but in IIT generally in advance, same type of question will be asked. Then you should not fear from the long chain. Only you count correctly and branch, that in that branch how many carbons are attached, that you have to not count. You count as a methyl or ethyl. Okay, that only you have to keep in mind. And at which carbon double bond is there, that you have to keep in mind. Then if same group is there, then you know that comma you will use. Then first I have told you. Now second is very easy. Actually here total 8 this is there, carbons are there. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons are there. And 1, 2, 3, 4. 4 double bond is there. 4 double bond. Then for the 4, what you will use? Tetra. For the 4, you will use the word tetra. And for the double bond, what you will use? Ene. Tetraene, Ene. Then now you have to only carbon number, you have to write carbon number. Then carbon 1, okay, that 1, 3, 5, 7. 1, carbon number 1, okay. After that, carbon number 3, carbon number 1, carbon number 3, carbon number 5, carbon number 7. You have to mention, because this carbon has double bond. You should start from the end. First end only, that is the 1. That you count. First, after that 3rd, then 5 and 7. Double bond is there. Hence you will write 1, 3, 5, 7. Octa means 8. Octa tetraene. Octa means 8. Octa tetraene. Correct? Octa tetra, because carbon number already mentioned. 1, 3, 5, 7. 1, 3, 5, 7 dash octa, because it is octane. Octane, from the octane, octa tetra means 4. 4 ene is there. And octa tetraene. That is this thing's nomenclature. And now that is the fourth one. Fourth one here, already long is there, but don't fear, I will give hint. Here actually carbon number 4 has this things 1, 2, 3, 4. Then carbon number 4 has this things. Carbon number 4 has ethyl group. 4 ethyl. Carbon number 4 has ethyl group. And after that, carbon number 2 and 6. Carbon number 2 and 6. They have methyl group. Carbon number 2 and carbon number 6 have methyl group. Then now, and after that, here you will see carbon number 4 has a double. Carbon number 4, 1, 2, 3, 4. Carbon number 4 has double bond. Carbon number 4 has double bond. And total number of carbon is 10. Carbon number, total number of carbon is 10. Correct? Then here you will do nomenclature how, then total number is 10. Okay, then that you have to use the word DAK. Okay, DAK you have to use, and because a long chain, that is the long chain has a this double bond E and E. Hence, finally you have to write carbon number 4. Actually, it is a double bond. Then what you will write? DAK dash 4 in. DAK dash 4 dash in. DAK dash 4 dash in. Always separation. That is the end you will write. But beginning, how will you write? Then beginning you have to start with the branch by this following the alphabetical order. Then it's ethyl you have to use first. At the carbon number 4 ethyl group is there. Then you have to start with ethyl, E letter alphabetically. Then 4 ethyl you will write, and after that 2 and 6, carbon number 2 and carbon number 6 has methyl group. Two methyl group is attached. One is at carbon number 2, other is carbon number 6. Then now 2, 6 you will write dimethyl. That's our nomenclature is over. After that, already in the beginning I told you, dash DAK dash 4 dash in. Like that way you have to do the nomenclature. This type of question is asked particularly in advance. Okay. And medical also sometimes may ask this question. Then this I have told you. You have to not fear from the long chain. Just you count how many chains are there, how many numbers are there, carbons are there, and branch you have to not count. Branch you have to separate. That carbon should not be counted. And after that naming time, how many methyl group is attached with any carbon, that carbon number you follow. And 2, 3 methyl group is there, then comma, that trimethyl you can write like that way. And at which carbon double bond is there, that you have to count it. After that, long chain carbon, what will the name? That you have write E and E finally you have to write. Don't forget. Then 2 times is there, then diene. 3 times is there, double bond, then triene. 4 times, then tetraene. Like that way you can write. And only in this question, one more question is there, that is based on this question only. That is most easy. What is actually asked here? I am reading the question. Calculate the number of sigma and pi bonds in the above structure, first to fourth. What was the question? Fourth question. In that question, all question, four parts are there. Then in each part, how many sigma bond and pi bond is there, that you have to count. Then how it is easy? Sigma bond and pi bond only have to count. Sigma bond and pi bond. Then nothing to do here. Only have to count single bond. How many single bonds are there? First to write the structure, complete structure, details. Okay, branch is there, then also CH3 is there. Then write CH3 in branch also CH. Everywhere bond should be clear. You can't write directly CH3. You have to mention the 3 bond, CH. Even in the branch also CH3 is there. C2H5 is also there. Wherever you write the details, complete hydrogen and carbon bond should be clear. Then after that, nothing is there. Just to count it, how many single bond is there. Then single bond means sigma bond. Single bond is sigma bond. And here you have to careful that in double bond is there. Double bond is there, then double bond, one bond is single bond. That you have to be careful. And if triple bond is there, that I will discuss in that alkyne time, but I am telling hint, if triple bond is there, then 2 bond will be pi and 1 bond will be sigma. That also you count in counting of sigma bond. Double means 1 sigma bond. Then now a structure they have given, only you have to count the single bond. And how many pi bond is there? Then pi bond is how many double bond is there? Then that double bond, one pi bond is there. Then suppose 2 pi bond is there, two double bond is there, then 2 pi bond only, and rest will be sigma bond. Then easily you can count and write. Then here, because you can't see, but here I am telling you only that by the question you can see and you can just count the single bond. And in double bond, how many double bonds are there? 3 double bonds are there, then 3 sigma bond, 3 sigma bond and 3 pi bond. Then that 3 you add in the sigma bond. Then in all 4 questions, same thing we have to do. It is most easy, but you should be careful only when double bond is there. Double bond is there, that time you should be very, very careful. Okay. Then this I have discussed. Now another you can say, this is there, isomerism is there. Okay, I told you every time you have to this isomerism and nomenclature, every time you have to learn for each case. Then I will talk about the isomerism, that is also very easy. Alkenes show both structural and geometrical isomerism. Okay, this alkenes both structure will show. That is the structural isomerism and geometrical isomerism. Structural isomerism, first I am telling you, as in alkane, just like alkane, ethene, that is the C2H4, and propene, C3H6, can have only one structure. Ethene and propene have only one structure, but alkenes higher than propene means 4, more than 4 and more than 4, higher than propene have different structure. Alkenes possessing C4H8 as molecular formula, C4H8, then 4 is there, then they have now these things isomers. Then first isomer you can write that carbon number 1 has a double bond. Carbon number 1 has a double bond. Then that is the one isomer, that is called BUT-1-in, very easy. Now other isomers, that is now at carbon number 2, they have double bond. Then now same way, BUT-2-in. Correct? 2 isomer I have told you. Now third is also there. Third possibility is there. Now suppose 3 propane is there. 3 propane, that is 3, this is there, chain of 3 carbon. First carbon is double bond, and with the middle methyl group is attached. Total 4. Molecular formula is same. Then now it will be 2-methyl prop, -1-in, because carbon number 1 double bond is there. Then all have same molecular formula but 3 structure. Correct? Then these are example of geometrical isomerism. A structure, that first structure and third structure where branch extension and branch, that and second and third second and third is also branch. First and third, first is a straight chain and third is the branch, and second and third again branch. These are the examples of chain isomerism. Chain, first is the straight and third is the branch. Third is the branch. Then first and third is the example of chain isomerism, and second and third also is the example of chain isomerism. And here one thing again I want to tell you, first and third, a straight chain and branch chain, first and third, that is one type. Other type is second and third, both are chain, both are already chain form. Then here last two, because carbon number 2 and carbon number carbon second and third CH3 group was attached. No, first and second is only this is changing. Position is changing. Carbon number 1 double bond, another carbon number 2 double bond was there. Then carbon number 1 and carbon number 2 means a structure first and a structure third is a branch, third is the branch, middle carbon CH3 is attached. Then these are the example of chain isomerism. And these things, second and third is also chain isomerism. But a structure first and second, where double bond is at carbon 1 and other carbon number 2, that is called position isomers. Okay. Then now today I am stopping only here, and now remaining parts I will discuss in the next class. Okay. Thank you.